Let us evaluate the integral of cotangent to the power of 3f(x). When dealing with either an integral of cotangent or a tangent, and your exponent here is an odd number, the first step would be to factor out either a tangent squared or a cotangent squared. Since what we have here is a cotangent, this would be the factored out cotangent squared x, and what's left, which is cotangent x. Note that by combining these two together, you would have a value of cotangent to the power of 3 of x. The reason that we would want to factor out a cotangent squared x would be to use this identity, wherein cosecant squared x be equal to 1 plus cotangent squared of x. Just in case that you will encounter a tangent, the identity for that would be secant squared of x would be equal to 1 plus tangent squared of x. But since what we have here is a cotangent squared x, we'll focus on that one first. And isolating cotangent squared x by putting 1 to the other side, it would be equal to cosecant squared x minus 1. By rewriting this into that, it would be the integral of cosecant squared x minus 1 multiplied by what's left, which is cotangent x dx. And distribute cotangent x on the parenthesis. And now it would be best to split this integral into two parts. This is a minus, so this would be a negative operation. And now let us focus on the first part, which is this one. We cannot integrate this simply as it is, so we would need to use u substitution. Let u here in this case be cotangent of x, and taking the derivative of this, it is equal to cosecant squared of x, multiply it by dx since it is respect to x. By isolating dx, it would be equal to du over cosecant squared x. Your objective in using a u substitution would be to cancel out the other term. So let's say we know that the derivative of cotangent x is cosecant squared x. And we can now cancel that by doing this. By substituting it, this would be the integral of cosecant squared x, and cotangent x is simply equal to u, and multiply it by dx, which is equal to du over cosecant squared of x. You can see now that cosecant squared of x would cancel, and that is the objective of using a u substitution, would be to eliminate the other term besides it, and copy the rest first. Now what we are left with here is u multiplied by du. The integral of u du is simply u squared over 2. And by putting u back into its original form, it would be cotangent of x. So this would be cotangent squared of x minus the integral of this one. Now that we cannot simply integrate cotangent x simply as it is, so we would need to put it into a simpler form. Cotangent x would be equal to cosine of x over sine of x dx. Tangent of x is equal to sine over cosine of x. And the inverse of a tangent is a cotangent. And since it is an inverse, its fraction here would also reciprocate, which is equal to cosine of x over sine of x, which is this one. That's just a reminder for that. And now, we would need to use u substitution in this again. We would need to eliminate one term here. But when doing a u substitution, you would want to put u here in the one that is in a more complicated position possible. For this problem, it would be the denominator. So let's put u here as sine of x. Take the derivative whenever you're doing a u substitution. Derivative of this would be equal to cosine of x, and multiply it by dx since it is respect to x. Isolating dx, it would be du over cosine of x. And this would be cosine of x over sine of x here is equal to u multiplied by dx, which is du over cosine of x. You can see cosine of x would cancel, which leaves you with du over u. We had reached this problem now. We would need to know the formula of logarithm in integral. The integral of dx over x would be equal to the natural log of absolute value of x plus c. Since what we have here would be integral of du over u, just put ln of u here. It is just a placeholder for the variables. It does not matter whether it is different or not, as long as it's consistent. And the integral of du over u would be equal to the natural log of absolute value of u plus c. And putting u back into its original form, it would be equal to sine of x. Thus, this would be the final answer regarding the integral of cotangent cube of x.